Hello everyone, and welcome to my Chemistry 225 presentation. In this presentation, I will be illustrating experiment number 18 in the Systematic Identification of Organic Compounds book. This experiment deals with the sodium hydroxide hydrolysis of amides and nitriles. Let's begin with an insight into the theory behind the experiment, beginning with the amides. First, you're going to have OH minus. It's going to do a nucleophilic addition into the C of the carbonyl group. Then, you're going to eliminate the nitrogen-containing group. Next, that group is going to be protonated. And finally, you're going to have those products, the sodium salt of the carboxylic acid, and either ammonia or a primary or a secondary amine. As for the nitriles, also OH minus, it's going to do a nucleophilic addition, but of course, it's into the C of the cyano group. Then, the N minus, it's going to be protonated. Next, you're going to get the amidic acid, which will undergo tautomerization to get an amide. And then OH minus, it's going to do a nucleophilic addition into the C of the carbonyl group of the amide. Then you're going to kick out the NH2, which is then going to be protonated. So for final products, you get the sodium salt of the carboxylic acid and ammonia. With this in mind, we can talk about the experimental procedure. So first, go get a test tube, and 5 milliliter of a 10% solution of NaOH, and pour that into the test tube. Then get 0.5 grams of your unknown, and transfer it into the test tube. And shake the test tube and check for the evolution of ammonia gas. Then, go get a hot plate, an aluminum block, and insert your test tube into the aluminum block. And go get a pink litmus paper, which you could coat with copper sulfate solution. Then put the pink litmus paper over the test tube. Now, if the exposed part of it turns blue, this means that you have the evolution of amine or ammonia, which is a positive result. Now know that if it was coated in copper sulfate solution, only ammonia will turn its blue. And ammonia, it's evolved from either primary amines, nitriles, or ammonium salts. Of course, as with every other experimental procedure, the final step is to clean up. Now transfer the reaction mixture into a designated non-halogenated organic waste container. Then rinse the test tube with some distilled water, and then acetone. Of course, I'd like to thank you for watching this presentation, and I hope that you found it informative, but you also enjoyed it. Goodbye.